Tired of adding new features to your code only for it to break? Today I'll give you 5 practical tips with examples that I use to make my code so robust that it literally catches errors for me, and that if I introduce a bug, it never spreads out to other systems. No, seriously, I will show you an example with a bug that would have normally been very nasty, but I was able to catch very fast, and not only that, but it didn't even break my program. In fact, you could even poke around this cheat engine and it still won't break your program with the tips that I'll give you. I will use the game that I'm working at as an example, but these tips apply to all areas of programming. Number 1. Set all your variables to 0. So even though I have several points in this video, they are all related and bring more stable code. Even though blindly applying these things will make your code way more robust, you need to understand how this full concept works. So I recommend watching all the video, because all the tips build together to hold up your code tight and bug free. So the first tip is to always initialize your variables to 0. You might say that, oh, it's not a big deal, or that you want to optimize your code by not initializing your variables. So let's break down these arguments. Maybe it isn't a big deal to keep some variables uninitialized in a class, because you know you will initialize them later. But tell me what happens when your program grows to be 30 files and 10,000 lines of code. You will for sure forget to initialize something, but more likely, another system will reset your class without initializing it correctly. But if all your members are always initialized to a default state, that by convention should be 0, you can just do this to clear your entire class to a default correct state. We'll talk about the optimization aspect later, because it is a big point to make, but now we still have a problem here. So, by always initializing all your things to a default state, you will stop bugs, but it will also be harder for existing bugs to manifest and spread out. So if you do have a bug, it's possible that you won't see it often. Why? Because that's what we are trying to do with all of the tips that I'm showing today. You make your systems more robust, so you don't get any bugs, and when a bug happens, it will be very small. But then, how do we make sure we catch all the bugs if we make them harder to manifest? This leads us to tip 2, and that is to use asserts, and it is very important. This is very similar to unit tests, but better in some ways. Like for game dev, it's very hard to write a unit test that is actually useful. Asserts, however, are very easy to add. And not only that, but this test can catch bugs that unit tests could potentially miss. So an assert is a special type of error, and it's not like an exception. It's an error for the developer, and it is there to tell you that you did something wrong with your code. For example, let's say we have a function that loads an image, and it expects that image to always be a PNG image, because you haven't implemented the other formats yet. Now this function is always used internally, so you just have to always pass a PNG to this image. But what if you forget about this 1 year later? Or what if someone from your team doesn't know that detail? Well, don't just write a comment there. Assert that the image type is a PNG. If this expression here isn't true, you'll get a big error. Now it's impossible to miss the bug, and it will even tell you where it happened. And if you run in debug, you can even press retry here, and it will bring you where the assert was triggered. So you know exactly what caused the bug. Now again, asserts are for programmer errors. If the user can somehow load any texture that he wants with this function, then you shouldn't use an assert. But rather, check that the texture was a PNG and report an error to the user if not. There's more stuff to cover here. There are also static asserts, and the normal assert in C++ only runs in debug mode, but I like making my own so that it also runs in release mode. So in the description, you have a video with more details and my assert implementation. But wait, things become even crazier. Let's say you make a big optimization with an asset manager that can determine when images need to be unloaded and when they still need to be using some counting references. A system like this is usually error prone. So how can you check that it is correct? Well, you could just do that. Literally, add some code that looks over all your loaded images and over all your things that need images and check if your system works correctly every frame. If not, you can trigger an assert. Now, this check may be expensive, of course. That's why you are making the optimization version in the first place. But you only need to check for this during development time. It is like a unit test, but one that runs while you are using your program. And this can be sometimes better than unit tests, because for unit tests you can easily miss an edge case. But if every single time you run your program, you check your system for correctness, you might just stumble into a weird edge case that was missed by unit tests. And I do this in my code. So for example, here the player always needs to have the part of the world where he is loaded. And I have a system that does that, but I also then check that it worked correctly. And trust me, it caught many bugs for me. So, when should you do this? I would say do this whenever you know your data can end up in a wrong state potentially. So maybe you know this if you study databases, but there is this concept called normalization. This is tip 3 actually, and it is so smart, I love it and I use it all the time. Let's say you store your entities in a vector. Nice and simple. And you have their position and other stuff stored there. But then, for some optimization purposes, you need to store their positions in a different data structure, like a tree for fast access. If this was a database, it wouldn't be considered normalized, because you have duplicate data. And this is a problem, because now your position can become incorrect in the second container. So, you want to have as little duplicate data in your system as possible. It might seem simple to just not forget to update your position in both places every time. But trust me, once your code grows, and you have more and more systems that have duplicate data, it becomes more and more fragile. You need a single weird edge case to break a link, and all your program will fall apart with weird bugs that are hard to detect and fix. So you have 4 options here. Option 1. Find a way to not duplicate your data. So in this case, you could, for example, store the position only in the second container, and link them together using an entity ID or a pointer. This isn't perfect either, because you still have a link between 2 data structures, the ID, that you need to maintain correctly. So option 2 is to simply not do this optimization, and just keep all your data in one place. Especially if you are a beginner, you might have a tendency to over-engineer your code and also optimize things that already run fast. Beginners always make the mistake of thinking that the system is slow without measuring it. The reality is that some optimizations that people do don't have any impact on the program, and if that optimization just makes your program more fragile, it's not worth it. But option 3, if you really need to have this data structure, instead of trying to do the optimized thing where you try to update elements in both containers every time, for some systems it is possible to reconstruct the second container every time from scratch. And this was just an example, but in this game I do this a lot. Saving data can be problematic, because it can become incorrect. So if I instead recalculate things every frame, I can't possibly mess it up. So every time the player moves, I just recalculate what terrain I should keep and what terrain I should throw away from scratch. It's just one small for loop after all. And you can apply this technique of recreating things from zero every time in many areas. Let's say you make some UI related stuff, and you have a number of buttons, font size and screen dimensions. You might try to construct a layout, save it, and update it only when things change. But that can be bug prone, and we are only talking about a few buttons here. So why not recreate the UI every time? Like it is literally a for loop that calculates the final dimensions and then draws the buttons. There's no way you introduce a bug here. And if you do still want to do that optimization with saving the layout and updating it only on changes, I'll show you later a tip for that. But getting back to our entity's position problem. If all of this isn't working for you because you have too much data and it would just take too much time to reconstruct it every time, you still have option 4. And that is to constantly check if your data is correct during production mode. So as I showed earlier, you can just add some code that uses brute force to check that your system is working properly. It may be slow, so worst case, you can add a dedicated button to run the tests when you want. It will catch a ton of bugs during development, and then you can just remove it in production. But wait, because the next tip will tighten everything together. Tip 4 is to have redundancy in your code. So let's go back to the image loading code. So you load the image from a buffer, and the image loading code can actually determine when the buffer ends. But what if that doesn't work correctly? Or what if your input is wrong? Why take that risk? You can also add a buffer size parameter, so you can never overrun it. And maybe also check that the image sizes are correct. If you have any problems, you can trigger an assert or return an error code, depending on your situation. Or let's say you reset your data every time you exit your game. Why not reset it as well when you enter? And I think you get the idea. So using all of these tips learned so far, add things to your code that might be redundant, but make it more robust. I like to, for example, create a normalization method on my classes. What it does is that it looks at all of its members, and it makes sure they all have correct values. Imagine the user messing with the config files, and putting some parameters that would break your program. So I like to call this method every time I read input from the user, or just from time to time to make sure things can possibly go extremely wrong. Or whenever I expect some arguments into a function, I like checking if that value actually works, and if not, I don't do anything. Or you can be very strict and assert that your data is normalized from time to time, or assert that your inputs are correct, so that if you get an assert, that means you introduced a bug somewhere in your code, and the assert helped you finding it. Next I have something that is very powerful, because it sits in between two systems that need to interact, and that's usually where problems arise. Tip 5 is my own, let's say, design pattern. So I don't know if these things exist, but I haven't seen it talked about, and I use it all the time. You can call it the isolated system pattern, but maybe I will come up with a better name for it. Let's say I want to implement this slider that controls my render distance. Ideally, The slider will directly control the render distance variable in my rendering code. That is the best way to do it. You don't duplicate any data. Unfortunately, we can't do that here. Every time I modify my render distance, I need to reallocate some memory and some other things. So what people would do is that they would have like a method called changeViewDistance. But this isn't perfect either. So in my case, the normalization code actually made the render distance update. And that's the kind of place where you forget to call the changeViewDistance code. But because of my pattern, the code can work no matter what you do. In fact, you can even open Cheat Engine, modify this value, and my code will still work. So how does it work? Well, on the rendering system, I store a value called currentViewDistance, or rather last frame view distance. And whenever I update the rendering system, I check if the new value, and that is the value from the slider or whatever input I have, is different from the old one. If so, I update my view distance and do the changes. In this way, no matter what I do, it's impossible to break this link. And that is what you want in your code. And if you also check here that your data is within acceptable values, and limited to that, bro, you can't even break your code, not even if you wanted to, and not even with Cheat Engine. And it has the added benefit that it is a lazy update. So if you modify your view distance many times in your program, the update will happen only once and only if needed. So you can modify the data and clamp it as many times as you want. And getting back to our UI example, if you want to optimize it, let's say you want to recalculate the UI only when the state changes, you can literally save the last state in abstract, and if the new state is different, you update your UI. And what's that? We have a bonus tip. Tip 6 is to have a simple procedural and slightly functional approach to your coding style. So let's look at an example. Let's say that you need to change all these red blocks in the world. You could make a list with all of them, but that means duplicate data. Why not iterate to the entire world every time to search for all the blocks that are red? And I know this seems slow and bad programming practice, but honestly, I would say it is bad programming practice to do it the other way around. And yes, I did that in my game, and there's a 0 performance penalty. But I'll talk about that in a second. So basically, what I did here, where I'm searching the entire world for the red blocks, instead of having a list of them, is kind of a functional style programming practice. Instead of having duplicate data, you just look through the data that you have as often as possible. So in this way, you reduce failure points. And also in general, have a simple procedural style of coding. You can use methods and classes, but have things step by step clearly, instead of having callbacks. In this way, it is way easier to debug your program. Like, just imagine randomly a callback triggers and calls a random function, and then you exit it and an error occurs. So, why did it occur? You have no idea, because you can't tell what callback was just called previously, or if it even happened. But with a procedural style of coding, you can just look at the code before the problem. Instead of having a callback to update my render distance, it always happens in the same place in my code. Now, let's address the elephant in the room, performance. So of course, adding all of these checks will impact your performance, and you need to be aware of that. But here is the thing, picture this. Bro, I can do multiplications in my head really fast. No way, what's 13 times 49? It's 17. That's not correct, bro. But it was fast. So I would rather have a slower code that is correct than a faster one that is buggy, because I can easily optimize it from there, or remove the redundant checks once I know I don't need them anymore. But if you are a beginner, and you code in a low-level language like C++, bro, trust me, you have no idea what performance means. Let's look at an example, where I'm iterating through all my map styles to search for specific tiles. Bro, for a modern computer, that's so fast, it's literally free to do it once a frame. So I don't want to see comments saying, oh bro, your game will run slow because of your bad programming practices. There are just a few checks here and there. I made this game using all those practices, and I would say it runs good. Guess what? It runs in debug mode right now, with no optimizations at all, using all the tips that I gave you in this video. And the only time it lags is when it loads chunks. As a beginner, before you measure your speed, you are not allowed to say that something is slow, period. Having some extra checks for all your entities is so fast that you won't see any difference. And for some smaller things, like checks that happen only one time in your code, or initializing your data to 0, the compiler and also the CPU are so smart that they can make those things literally free. Like seriously, 0 microseconds difference. So if you do C++ and you thought about performance while I was talking about these things, trust me, you don't even realize how much you underestimate your CPU and your compiler. So please go watch this video to also solve that. Maybe check out my Minecraft clone, or how I never have memory leaks. See you there.